going to have a discussion on applications of a network theorem. So we have studied various network theorem like Norton's, superposition, Thevenin's theorem in circuit analysis and devices subject. So these network theorems are mainly used to simplify the complex circuits. And by using these networks theorem, we can analyze the various circuits. We can identify the performance of the various circuits. And these network theorems have been employed in various fields like embedded IoT, etc. So in today's session, we are all going to discuss about the application of these network theorems in various fields. So after 5 minutes, we can start our discussion. Okay, let's start the discussion.
Hello everyone, I am Shivani from ECE. We are currently studying about various theorems. So let's start the discussion. I am going to talk about the applications of the theorem, network theorem. Simplification of complex circuits. Thevenin's and Norton theorems help to reduce the complicated circuits to simpler equivalent forms. A simple voltage or a current source with the resistor. This simplification makes it easier to analyze the behavior of specific components in the network. Design and analysis of the electrical networks. In a power system, these theorems are used to analyze the load distributions, fault currents and the voltage drops. Superposition theorem helps in analyzing the circuits with the multiple sources by considering one source at a time. And testing and the troubleshooting. Network theorem assist in isolating for a circuit during fault diagrams.
So for analyzing and testing and troubleshooting circuits, we require the network theorems. So Shivani has discussed about the superposition and Norton's theorem.
And I'm Yoganila. I'm going to share a few points about superposition theorem. Analyzing circuits and multiple sources. Superposition helps you to solve circuits that have more than one voltage or current source by considering one source at a time, making the problem easier to solve. Signal analyzing in communication and systems. In electronics and communication engineering, it is used to study how different signals affects the systems when applied at the same time. Designing amplifiers and filters. It amplifies the process of calculating the output when circuits have both AC and DC sources or multiple signal paths. Testing circuit response. Used to predict how a circuit will behave when multiple sources are active by checking one source at all time. Control systems. Helps in analyzing system response where inputs and outputs are from different control points.
So for analyzing the signals, we require superposition theorems. So in communication system, superposition theorem plays a major role. And any more points to say? Yoganila? Okay. Next.
So myself Vishnu. Here are some points of application of Thevenin's theorem. Simplifying complex circuits. It reduces a large circuit to a simple equivalent circuit with just one voltage source and one resistor. This makes our analysis much easier. Analyzing load behavior. We can find how different loads like bulbs, motors and sensors behave when it conducts to a circuit without reducing an entire analysis system. Designing of electronic devices used in designing power supplies, amplifiers and sensor circuits, where components need to match specific voltage across or resistors. Fault detection and testing. It makes easier to isolate and test sections of circuits by replacing complex parts with Thevenin's theorem. Power and transfer efficiency, used in combination with maximum power transfer theorem to ensure that devices get more power from the source.
So for analyzing the load behavior, for analyzing the system efficiency, we go for the superposition theorem.
Myself Smaila, and some students discussed about various points on network theorem, and I am here to discuss some points on Norton's theorem. Norton's theorem simplifies its complex electrical circuits into a simple circuit, source with parallel with resistor. But doing it manually for the long circuits can be time consuming to prove the errors. I am here to say some points on applications of modeling and simulations. Tools like MATLAB, PSpice are helped by creating a digital model of a circuit, and Norton's theorem's equivalent by setting the load resistance to 0 and removing the load resistance to the equivalent circuit.
So we can use tools like PSpice to reduce the time complexity, right? Okay, next.
So myself Yamna, so I am going to discuss about the maximum power transfer theorem. So maximum power transfer theorem ensures that the maximum power is transferred to the load when load resistance which is equal to the source resistance. So here I am going to discuss about the applications of maximum power transfer theorem. So communication system, matching antenna and transmitter impedance for strong signal transmission. Audio systems, matching speaker and amplifier impedance for better sound quality and loudness. So power electronics ensures efficient power delivery to the loads in inverters and converters. So battery power devices, optimizing power drawn from batteries to improve battery life.
So mostly it is used in the antenna part. Next.
So hello everyone, I am Tharni. I am going to talk about Norton and Thevenin's theorem used in control system and signal processing applications. Network theorems helps in designing and analyzing electrical circuits used to control systems like automatic fans and robots, and in signal processing like filters, amplifiers and communication systems, etc. By simplifying circuits using Thevenin's and Norton's theorem, engineers can understand how signals behave, filter out unwanted noise, and amplifiers working, improve system stability and performance. So in simple words, they make it easier to build smarter systems that respond currently and process signals clearly.
We discussed about the applications of the network theorem. As Dharni mentioned, engineers use this network theorem in analyzing the circuits. So by analyzing that, they will be finding out what is the actual performance of the circuit. Based on that, changes can be made. So as you all discussed, network theorems can be applied in various fields like embedded, IoT, and even Vishnu Vishni mentioned about the antennas, right? Antenna part, antenna analyzing, these network theorems has been employed. So it plays a vital role in the communication part also, in signal processing and in filter design, everything. These network theorem plays a major role. So thank you all for your valuable points. Thank you.
Thank you.